1 minute ago, the story of the moon quietly changed. Not with an explosion, not with a rocket launch splashed across every news channel, but with a data release that scientists are calling one of the most destabilizing lunar findings in 50 years. And if you have not heard about it yet, you are about to understand why people who study space for a living are suddenly talking in a very different tone. For centuries, the moon was the one constant. It rose, it set, it pulled the tides, and it asked nothing of us in return. We assumed we understood it. Gray, cratered, dead. A finished chapter in the solar system's history written 4.5 billion years ago, and never revised since. That was the comfortable version. The version taught in classrooms. The version that let humanity look up at the night sky and feel like it already knew the ending. That version just broke. Because China's Chang'e 6 mission, the same mission that made history in 2024 by dragging nearly 2 kilograms of material off the moon's far side, the side we can never see from Earth, has been quietly rewriting lunar science for the past 2 years. And in the most recent wave of research, published through the Chinese Academy of Sciences and in the journal Nature, scientists have confirmed something that should not exist under the old model of the moon. A lunar mantle on the far side that is chemically starved, drier, and far more reduced than anything found on the near side we've been staring at since Galileo. In plain language, the near side and far side of the moon are not the same object. They evolve differently. They have different chemical fingerprints, and nobody fully knows why yet. That single detail might sound small, but scientists worldwide have already published over 150 research papers building on these samples in less than 2 years. That is not a footnote in a science journal. That is an entire global research industry building itself around rock and dust that only one country on Earth currently has access to. And it gets stranger. A study published in February of 2026 in the Proceedings of the National Academy of Sciences found that the ancient impact that created the moon's massive South Pole Aitken Basin, the largest, oldest, and deepest crater in the entire solar system, did not just scar the surface. It reached down and altered the moon's interior chemistry, driving volatile elements out of the deep mantle in ways researchers had never confirmed before. Think about that for a second. An impact that happened billions of years ago is still shaping what we're discovering about the moon today. The moon is not just a battered rock. It is a layered record of violence and change that we are only now learning how to read. And this is where it stops being pure science and starts becoming something else entirely. Because China is not simply studying the moon out of curiosity. Over the past 2 decades, its program has moved in a deliberate, almost military sequence. First, orbiters, then precision landings, then a mission to the far side, something no other nation had ever pulled off. Then sample return, not once, but twice. Each mission did not just gather data, it built infrastructure, expertise, and continuity. This is not a country visiting the moon. This is a country learning how to operate there permanently. And that difference changes everything about how we should be reading this new data. Because when new mineral discoveries start appearing, and they have, 4 new lunar minerals identified by Chinese researchers in just the last few years, including 2 confirmed as recently as April 2026, rare earth-rich crystals with names like magnesio, andesite, and chang'e cerium. These are not just entries in a scientific catalog. China now ties the United States for the most lunar minerals ever discovered by a single nation. That is not a coincidence. That is the direct result of a 20-year strategy finally paying off. So here's the uncomfortable question hiding underneath all of this. If the moon is chemically stranger, more resource-rich, and more structurally active than we assumed, and if one country is the only one currently holding the physical samples to prove it, what does that mean for the next 10 years of space exploration? What happens when science stops being about curiosity and starts becoming about who gets there first, who owns what they find, and who writes the rules for a place that suddenly matters more than anyone expected? Stay with me, because the next part of this story involves water, a hidden crater at the bottom of the world, and a mission launching within months that could change the entire timeline of human presence on the moon. Here is where the story stops being about rocks and starts being about resources. Because everything we just covered, the strange mantle chemistry, the new minerals, the impact that reshaped the moon's interior, all of it points toward one region that scientists and space agencies now treat as the single most important piece of real estate in the entire solar system, the lunar South Pole. Not because it looks dramatic from a telescope. It doesn't. It's a jagged, shadowed, brutal stretch of terrain near the bottom of the moon. But operationally, it might be the most valuable few hundred kilometers humanity has ever laid eyes on. Because of the moon's tilt, certain craters at the South Pole never receive a single ray of sunlight. Not for a day, not for a year, not for billions of years. Scientists call these permanently Shadowed regions, and inside them, temperatures drop cold enough to trap and preserve volatile materials indefinitely. Materials like water ice. And water changes everything, not symbolically, practically. Water is not just something astronauts drink. Split apart, it becomes hydrogen and oxygen, which means breathable. Air and rocket fuel and radiation shielding, all extracted from ice that has been sitting there since before life existed on Earth. A patch of frozen lunar dirt can become a gas station, a place to refuel before pushing further into deep space. And that reframes the moon completely. It stops being a destination. It becomes a stepping stone. This is exactly why China's next mission matters so much, and why the timing of everything we just discussed is not a coincidence. Chang'e 7 is scheduled to launch in the second half of 2026, and unlike previous missions, it is not built primarily to study rocks. It is built to hunt water. The mission includes an orbiter, a lander, a rover, and something almost nobody outside the space community is talking about yet. A hopping probe equipped with a water molecule analyzer, designed specifically to leap into permanently shadowed craters that no wheeled rover could ever survive. This thing is meant to jump into total darkness, take a reading, and confirm what decades of remote sensing could only guess at. Is there truly usable water ice down there, and how much of it exists? Now hold that thought, because here is where the recent findings from Chang'e 6 suddenly connect in a way that should make you sit up. Remember, the far side samples already showed a different, more chemically reduced mantle than the near side. Reduced, in this context, means low in oxygen-bound minerals, which some researchers now believe may be tied to how volatile elements, including hydrogen-based compounds, were pushed and redistributed by that ancient South Pole Aitken impact. In other words, the very same violent event that scientists say reshaped the moon's interior may also explain why the South Pole region behaves so differently from the rest of the moon, and why it may be holding onto water and other volatiles that other regions lost billions of years ago. That is not a small connection. That is the moon's ancient violence and its modern resource potential turning out to be the same story, just read from two different chapters. And this is precisely why what looks like slow, methodical Chinese lunar science should not be read as slow at all. Every mission builds on the last one with almost frightening precision. Chang'e 5 proved sample return was possible. Chang'e 6 proved it could be done on the far side, something the United States and Soviet Union never attempted. Chang'e 7 is now aimed directly at confirming whether the resource everyone has been theorizing about for 20 years is actually sitting there waiting. And Chang'e 8, expected around 2029, is designed to test whether lunar soil can actually be used to build structures on site. Not simulated, not theorized, physically 3D printed and tested on the lunar surface itself. Layer these missions on top of each other, and you're not looking at scientific curiosity anymore. You are looking at the blueprint for a base. China has already stated its ambition publicly: crewed lunar landings by 2030 and a permanent outpost near the South Pole called the International Lunar Research Station sometime in the 2030s, built with partner nations including Russia, Pakistan, and others. Meanwhile, the United States is racing along a parallel track with its own Artemis program, targeting its own crewed lunar landing around the same window, and building a separate coalition of more than 40 nations through the Artemis Accords. So ask yourself the question. These findings are quietly forcing onto the table. If the South Pole genuinely holds accessible water ice, and if new lunar minerals like the rare earth-rich chang'e family turn out to be commercially significant, and if two competing programs are both racing toward the same patch of frozen, shadowed crater at the bottom of the moon, what happens when both of them arrive around the same decade? Because water is not the only thing hiding in that ice. Scientists have also been tracking deposits of helium-3, a rare isotope almost non-existent on Earth but potentially valuable for future fusion energy, embedded in lunar soil across multiple regions, including areas studied by Chang'e 5. It is untested as a real fuel source today, but the mere possibility has already ignited what several researchers now openly call a lunar resource race. Suddenly, the moon is not one shared, empty rock floating above us. It is starting to look like structured, mapped, competitively valuable terrain. And terrain like that, throughout history, has never stayed uncontested for long. So what happens next? What happens when the hopping probe actually reaches one of those permanently dark craters? What happens when the water is confirmed, not theorized? That is where this story goes next, and it is bigger than the moon itself. Let's slow down for a second, because this is the part of the story most people scroll past without realizing what it actually means. We are not talking about a hypothetical future anymore. We are talking about a specific dated mission, launching within months, aimed at confirming whether one of the most strategically important resources in the solar system is sitting exactly where scientists think it is. And here's the detail that should genuinely unsettle you. This is not China's first attempt to understand lunar water. Back in 2023, researchers using Chang'e 5 samples announced something that barely made headlines outside the space community, but should have. They discovered a method of producing water directly from lunar soil itself, by heating the minerals until hydrogen trapped within them reacted and released water vapor. Not water hidden in a shadowed crater. Water manufactured from ordinary lunar dirt, using a process researchers described as capable of producing it in large quantities. Read that again. If usable water can be extracted from regular lunar regolith almost anywhere on the moon's surface, and if additional reserves of actual ice exist in the permanently shadowed craters at the South Pole, then the entire justification for treating the moon as a barren, resource-poor rock collapses at once. This is not a single lucky discovery. This is two independent lines of evidence, one from manufactured extraction, one from natural ice deposits, both pointing toward the same conclusion. The moon may have far more accessible water than almost any model assumed a decade ago. Now connect that to the new minerals. In April 2026, Chinese researchers confirmed two additional lunar minerals, magnesio-candesite yttrium and change'e cerium, both classified as rare earth-rich phosphates identified from two separate sources, chang'e 5 regolith and, remarkably, a lunar meteorite named Pakapake 0-5, discovered in China's Taklamakan Desert in 2024. That detail matters more than it sounds. It means Chinese researchers are no longer only relying on samples brought back by spacecraft. They are also finding lunar material that fell to Earth naturally and cross-referencing it against mission data to build an increasingly detailed map of what the moon is actually made of. That gives China now 4 confirmed lunar mineral discoveries, tying the United States for the most of any nation on Earth, a milestone that took the Soviet Union and the US roughly 50 years to reach, and that China has matched in under 4 years. And barely 2 weeks after that announcement, researchers confirmed an 11th lunar mineral worldwide, isolated from that same meteorite, a rare earth phosphate with an unusual fluorescence under ultraviolet light. Scientists studying it noted something worth sitting with. Minerals that form under conditions never replicated on Earth can occasionally reveal properties useful for entirely new materials and technologies back home. In other words, this isn't just about understanding the moon anymore, it's about what the moon might hand back to us. This is the pattern that keeps repeating throughout this entire story, and it's worth naming directly. Every time scientists assume the moon has told its full story, a new mission, a new sample, or a new analysis proves that assumption wrong. The moon was supposed to be geologically dead. Then, Chang'e 5 samples revealed volcanic activity as recent as 2 billion years ago, pushing the moon's active lifespan a full billion years further than anyone had calculated. The moon's near and far sides were supposed to be roughly similar. Then Chang'e 6 proved the far side mantle is chemically distinct, drier, and more primitive. The South Pole Aitken impact was supposed to be an ancient surface event. Then 2026 research revealed it reshaped the moon's deep interior chemistry. Every single assumption, one after another, has been quietly dismantled by actual physical evidence. So when you hear that Chang'e 7 is about to send a hopping probe directly into a permanently shadowed crater with a water molecule analyzer strapped to it, you should not treat that as routine science news. You should treat it as the moment the last major untested assumption about the moon is about to be checked against reality. Not modeled, not estimated from orbit, physically measured, on site, in the dark. And here's the geopolitical layer underneath all of this, because it cannot be separated from the science anymore. Mahesh Anand, a planetary scientist at the Open University, said publicly that the work coming out of Chang'e 6 samples is turning multiple well-established lunar theories upside down, and that scientists across the world are having to re-examine assumptions that had stood for decades. When a researcher with no stake in Chinese national interest says something like that, it tells you this isn't propaganda, it's peer-reviewed science forcing a correction. But peer-reviewed science does not exist in a vacuum. China's space agency has openly stated its ambitions. Crewed lunar missions by 2030, a permanent research station near the South Pole through the 2030s, and international partners already lined up. The United States, through NASA's Artemis program, is targeting its own crewed lunar landing around a similar window, with more than 40 nations already signed onto a competing framework. 2 major coalitions, 1 shared destination, 1 increasingly confirmed resource, sitting at the bottom of the world in permanent darkness, waiting to be claimed first. So here's the real question hiding underneath every headline about a new mineral or a new mission. It was never really about rocks. It has always been about who gets to the water first, who gets there with enough infrastructure to actually use it, and who ends up writing the rules for a resource that, for the first time in human history, might not belong to any single nation by default. Because whoever confirms the ice and whoever builds the first working base near it does not just win a scientific milestone, they win first. access to the fuel station of the rest of the solar system. And that changes what 1 minute ago actually means. It's not just a headline device, it reflects something real, a slow-moving discovery process that has been quietly accelerating for years and is about to hit a confirmation point that could redraw the next 50 years of space exploration. So let's bring this all the way back to where we started and ask the question this entire story has been building toward. What happens the moment humanity confirms, beyond doubt, that the moon holds usable water, usable minerals, and a usable location to build from? Because that moment is no longer decades away. Based on everything researchers have published just in the past 2 years, and based on a mission scheduled to launch within months, that moment might be closer than most people realize. Think about the pace of what we've just walked through. In 2024, Chang'e 6 became the first mission in human history to bring samples back from the far side of the moon. Within a year, that data was already producing dozens of peer-reviewed papers. By 2026, that number passed 150, revealing a mantle that behaves nothing like the near side we've been staring at for our entire existence as a species. In the same window, separate teams confirmed that the ancient impact which formed the solar system's largest crater didn't just scar the surface, it reached down and altered the moon's deep internal chemistry. And in April 2026 alone, 2 new rare earth-rich minerals were confirmed, followed weeks later by an 11th lunar mineral discovered worldwide, pulled not from a spacecraft, but from a meteorite that fell to Earth and was found in a Chinese desert. That is not a slow trickle of discovery. That is an acceleration curve. And acceleration curves in science usually mean one thing. We are getting closer to a threshold, not further from one. Now overlay Chang'e 7 onto that timeline. A mission built specifically to answer the one question every other discovery has been circling around, without confirming directly. Is there truly water ice in real usable quantities sitting inside those permanently shadowed craters at the lunar South Pole? With a hopping probe designed to jump into total darkness and take a direct reading, this mission is not exploratory in the old sense. It is confirmatory. It exists to close the loop on 20 years of theory. And if it comes back with a yes, and multiple independent lines of evidence already suggest it will, then the moon stops being a symbol. It becomes infrastructure, a place where fuel is made instead of shipped, a place where materials are processed instead of hauled up from Earth's gravity well, at enormous cost. A place that makes everything beyond it, Mars missions, deep space probes, orbital manufacturing, dramatically more achievable because the hardest part of space travel has never been the distance. It has always been the fuel and the weight you have to drag with you from the ground. This is the part of the story that should genuinely stay with you. For all of recorded human history, the moon has been the one fixed point. It shaped our calendars, our tides, our myths, our earliest attempts to measure time itself. It felt finished. Emotionally, culturally, scientifically, finished. And yet, here we are, watching researchers dismantle that assumption piece by piece, using evidence gathered just in the last 2 to 4 years. The moon's volcanic activity ran a full billion years longer than believed. Its 2 hemispheres are chemically distinct in ways nobody predicted. Its oldest, most violent impact reshaped material we assumed was untouched. And its darkest craters may be holding onto water that could fuel humanity's next 50 years of expansion into the solar system. If something that close, that visible, that supposedly understood can still surprise us this dramatically, it raises an uncomfortable question about everything else out there that we've already decided is finished. Mars, the icy moons of Jupiter and Saturn, the asteroid belt. How many of those are only labeled settled science because nobody has looked closely enough yet? With the right instruments, at the right resolution, with the right intent. That is the real headline hiding underneath China's new moon discovery. It was never really about one mission, or one mineral, or one crater. It's about the fact that proximity does not equal understanding. We have been staring at the moon for the entirety of human civilization, and we are only now, in these last few years, starting to actually understand what it is and what it might become. And that brings us to the part of this story that will define the next decade, not just for China, but for every space program on Earth. 2 coalitions are now moving toward the same destination. China's program, alongside partners like Russia and Pakistan, is targeting crewed landings by 2030 in a permanent South Pole research station through the 2030s. The United States, through Artemis, is targeting a similar window for its own crewed return, backed by more than 40 nations under the Artemis Accords. Both are converging on the same shadowed craters. Both are chasing the same frozen resource. And for the first time since the original space race of the 1960s, the outcome is not guaranteed to favor whoever arrives. First, symbolically. It may favor whoever arrives first with the infrastructure to actually stay. So here's the honest way to close this out. This is not a story about a single dramatic discovery that happened 1 minute ago and then fades from the news cycle by next week. This is a story about a pattern, one that keeps repeating every time we look at the moon a little more closely than the generation before us. And each time that pattern repeats, the stakes attached to it get higher. Because now the moon isn't just something we study, it's becoming something we might actually build on. Chang'e 7 launches later this year. When that hopping probe drops into total darkness and takes its first reading, you will be watching the moment humanity either confirms or delays one of the most important resource questions of this century. So here's what I'll leave you with. If the moon, the one object we thought we already understood completely, still had this much left to reveal, what do you think we're going to find out there next? Drop your thoughts in the comments, and if this kind of deep dive into space, science, and the new global race for the moon is something you want more of, make sure you're subscribed because this story is only just beginning.